Hi, everyone. Sorry I can't be with you in person. Something came up. So to support your learning and to not slow down, I am here making a video. Please be good to the substitute and listen to what they have to say. Please don't abuse the washroom system. And I hope that you continue working hard, even though I'm not there. Luckily for you, today's lesson is not necessarily new, but I wanted to focus your attention on a couple of things we practice. Excuse me, things we practiced yesterday, but with, again, a little bit more focus because it may come in handy sometime in the future when we start talking about this thing called factoring. So here we go. If you remember, when we had a binomial that was to the power of something, it was very easy to make a mistake. That is, it was so easy to apply that square onto the first binomial, apply that square onto that second binomial, and think you're done. But contrary to popular belief, that is not the answer. Okay, that is why we attempt to open it up and do distributive property. That would be the first value. Let me use a highlighter. The first value, the first term of the binomial is going to have the opportunity to multiply with every term in the second binomial. Once that's done, we have the second term of the first binomial getting a chance to multiply with every term in the second binomial. Okay? When you do that, you realize that yes, we have a squared, yes, we have b squared, but there is a term in the middle that you forgot about if you were to apply it as you did before. It's so easy to make a mistake and forget about that middle term, so don't do it. Today's focus, what I wanted you to pay attention to, was that when you have a binomial multiplying with itself, whether it's an a plus b or an a minus b form, the resulting trinomial is always going to have the pattern of the first term, right? The first term squared. Let me try to have that as a highlighter. The first term squared, the first term squared, the last term squared, the last term squared. And then the middle term is going to be the first term multiplied by the second term times 2. So check it out. I'm going to give you 3 examples down here, and I hope that it will be enough for you to catch the pattern. Even if you don't catch the pattern, it's okay. We'll have more opportunities to see it. But for now, see if you can at least be able to multiply these binomials without making mistakes. Here we go. So when you have a binomial, so this is what we're going to do. It's an example I've already filled out for you. This is going to equal, please rewrite it as 2x plus 3 multiplied with 2x plus 3. And that is going to be, again, the first term gets a chance to multiply with everything in the second term. So 2x times 2x is 4x squared. 2x times 3 is 6x. Once the first term is done, the second term gets a chance to multiply with every single term in the second binomial. So 3 times 2x is 6x. 3 times 3 is a 9. And so you take that and then you simplify by grouping like terms. You get yourself 4x squared plus 12x plus 9. So this is what's unique about questions that have a square. That is, if it is a binomial multiplied by itself, 2x times 2x is 4x squared. 3 times 3 is 9. In the middle, so, the pattern was this number, 2x, times that number, 3, times 2. So 2 times 3 times 2, you plug that in the calculator, you will get 12, and you have 1x. This is where the 12x comes from. Okay? And that's it. That's the first pattern I wanted you to see. Let's try this one again. Rewrite this, 4x minus 5. 4x minus 5. And then go ahead. 4x gets a chance to multiply with every single term in the second binomial. 4x times 4x, that would be 16x squared. 4x times negative 5 is negative 20x. Negative 5, now it's negative 5's turn. Negative 5 times 4x is negative 20x. And negative 5 times negative 5 is positive 25. Now, let's pretend you saw the pattern. And instead of going from here, I'm going to go straight from here because I know the pattern. What's 4x multiplied by itself? 16x squared. What's negative 5 times negative 5? Well, it would be positive 25. Then what is 4x times a negative 5 times a 2? Well, 4 times negative 5 times 2 would be negative 20. And the x is just on its own is negative 20x. Sorry, negative 40x. I apologize. That is negative 40x. And it matches with what we did before. So it's just a coincidental pattern that makes certain things nice. And when we do this thing called factoring in the future, recognizing this pattern may come in handy. Okay, let's move on. I know this might be a little bit fast. Please note that this video is going to be uploaded into our Google thing. So any parts that you did miss in class, please use whatever technology tool you have and you can watch the video and refill it. Okay, but we're basically done here and then we're going to do some examples on the bottom. But the second example I wanted to show you was a difference of squares. Take a look. I have with me a square minus a square. Where does that come from? So another interesting pattern is if I have a binomial, that's something plus something, multiply with the same binomial, but it's a negative, which is called a conjugate. So if I am multiplying binomials that are conjugates of each other, you're going to end up with a difference, a subtraction of two squares. So let me show you how this works. I am going to do the thing where I take the x value, I'm going to multiply it to both terms, and then I take the 4 and I'm going to multiply it to both terms. Okay, so x times x is x squared. X times negative 4 is negative 4x. I'm done. So it's positive 4's turn. Positive 4 times x is 4x. And positive 4 times negative 4 is negative 16. If I were to group like terms, take a look at these two terms here. A negative 4x, a positive 4x. They're going to essentially add and subtract into a 0. All that's left is x squared and a negative 16. If you get a chance to recognize, so this pattern is a little bit easier than the previous one. If you notice that the two binomials are conjugates, you can actually skip this portion and be like, okay, I know that because this is a conjugate, a multiplication of conjugates, all I have to do is take a look at the first term and square it, look at the second term and square it, and leave a subtraction in between. And it's so simple if you can catch it. Y times y, y squared. And negative 5 times positive 5, negative 25. That's literally it. You're done. Okay. And just to prove it to you, I'll do this middle one. If I multiply this out, this gets y times y, y squared. And then y times 5. So y times y, and then y times 5. Positive 5y. Negative 5 times y, negative 5y. And then negative 5 times 5, that's negative 25. And that's this part. This positive 5y and this negative 5y will essentially turn into 0. Pretty interesting stuff. Now, yeah, at this point in time, something I probably should have mentioned to the substitute, you should feel free or ask the substitute to pause the video when it is appropriate so that you can sort of end up copying. It might be a better way to use your time. Instead of actually expanding the last example, I am going to continue on and just multiply here. 2x, 2x, that's 4x squared. And negative 3, positive 3 is negative 9. I'm done. So sometimes being able to recognize patterns will save you a lot of time. Even if you don't see the pattern and you end up multiplying everything, you will see that you are doing this every single time. And you will feel sort of annoyed because you feel like it might be a waste of your time. But that's what mathematicians do, right? They see these patterns and they get lazy. And so they will develop whatever shortcuts they can to save themselves time. So there you go. What I'm going to do for the remaining couple of minutes is to try and show you these examples in action. And your homework, your expectation is to try to finish the remainder of this page so I could check it. Okay, is really important. And I'll tell you right now, I am going to provide for you some kind of entry card or an exit card or something. It's going to be like a little bit of a pop quiz just to see how well you've been doing your homework. It's not really going to be worth marks, but it will give me some feedback as to how much you've been practicing. This expanding business is going to be with you for, I'm going to say, the rest of your math career. So at least for the rest of this semester. So don't slack. All right. 14b. If you want to do this on a blank piece of paper, you can. 3a minus 5b squared. Now, just in case I make a mistake, I am going to rewrite all of this as two binomials multiplied by another binomial, and then doing distributive property. 3a multiplies with this term and then that term. So we've got 9a squared negative 15ab. Next, negative 5b multiplies with both terms. That becomes negative 15ab and positive 25b squared. If you group like terms, you will get 9a squared minus 30ab plus 25b. And that is when you will realize, oh, it's that pattern. It's that thing where you have the two binomials that are identical with each other. So I could have just done 3a squared negative 5b squared, and then 3 times 5 times 2, right? 3 times 5 times 2 is negative 30 with the a and the b. So this is what I mean. So this time, now that I know this is going to be a kind of a pattern, I am going to try to employ the pattern here without having to actually multiply it out. I see that these two binomials are conjugates of each other. And so it's going to be a difference of squares. What does that mean? It means that this number is going to be 5m squared. This number is going to be 7n squared. And in between it is going to be a subtraction. It's going to be 25m squared minus 49n squared. Again, it's just a pattern. Do you have to memorize it? No. Can you just multiply it out like you always did? Absolutely. But it's helpful. And just trust me when I say it'll be helpful in the future. All right. So number 13 is an example of a communication question that could pop up on a test. If you look on the bottom, we have a whole bunch of K-style questions, just very basic. Do you know how to do the actual math portion or not kind of thing? Please do as much of this as you can. In fact, you should have enough time in class to do all of these flawlessly. I will provide an answer key for these in the Google Classroom as well. Suffer well, and I will see you when I get back.